Okay, for the last lesson involving radicals, we're going to be solving radical equations that actually have two different radicals in them. So, the first thing we need to do is state the domain or the restrictions. Now, we need to remember that in order for the restrictions to work, we need a restriction that encompasses something that will work for both possible radicals. We're going to isolate a radical, we're going to square both sides, and then typically what happens is if we have two different radicals, once we have done that, we're going to wind up with another radical left over after we have squared both sides. So we're going to have to do the entire process over again. Then we're going to solve for the variable, and like in all the cases, we're going to need to prove that the variable actually works. So, for the first case, we have two different radicals that exist here. Well, I'm going to say that for the first radical, if x minus 1 has to be greater than or equal to 0, x has to be greater than or equal to 1. For the second radical, if 2x plus 3 has to be greater than or equal to 0, then x has to be greater than or equal to negative 3 over 2. Well, if I'm doing a greater than, then I need to take the greater than of the bigger number. Picture it like this. If I have a number line, and I have the number negative 3 over 2, and I have the number 1, and they're both going to be greater than that point, then this one's going to increase, this one's going to increase, and they both overlap. It solves for both of them when it is greater than the bigger one, or greater than 1, which means that this one is actually not going to cover all my possibilities, only this one will. So I'm going to state that my solution, or my restriction, is going to be set so that x has to be greater than or equal to 1. That's going to cover possibilities that work for both. Alright, now I'm going to follow my second step, and I'm going to square both sides. I don't need to isolate because they're both already isolated. When I square the left-hand side, I'm going to wind up with x minus 1. And when I square the right-hand side, I wind up with 2x plus 3. If I want to move the x's to the left-hand side, I'm going to get negative x is equal to, when I move the 1 to the right side, positive 4, or x is going to equal negative 4. And as soon as I see this, I take a look at my restrictions, I take a look here, I don't even need to verify it, I know it's going to be an extraneous root, because it doesn't even fit within my restrictions. Alright, let's take a look at the second case. Well, here, when I'm solving for my restrictions, I'm going to wind up with two possibilities. If I'm using the one on the left-hand side, it's going to be x has to be greater than or equal to 7. If I use the one on the right-hand side, it's going to state that x has to be greater than or equal to negative 2. Well, if it's greater than, it has to be greater than the bigger number, which means that I have to pull from this one, and that one actually is not going to count towards my restrictions. Then I'm going to solve it. Well, it's already isolated, but one thing I do find is people get confused when you have the dividing by number for how it's going to work. For the most part, people don't really like the denominator, so I'm actually going to multiply the 2 into both sides, just so that I'm not dealing with fractions. And I'm going to say that 2 root x minus 7 is going to equal the square root of 2x plus 4. From this point, I'm going to square both sides. And I'm going to say, well, the 2 squared here is going to give me a 4. The root x minus 7 squared is going to get rid of the radical. But I'm going to put it in brackets to make sure I multiply it out properly afterwards. And on the right-hand side, I'm just going to wind up with a 2x plus 4. Now I'm going to state that I have 4x minus 28 is equal to 2x plus 4. Move the x's to the left-hand side, and I get 2x's. Move the negative 28 to the right-hand side, and I get 32. Or x is equal to 16. Now I just need to verify it, see if this actually works. Well, 16 fits within my solution range, so it's possible that it is a value that's going to work, but I still need to check it by verifying. The square root of 16 minus 7 is equal to the square root of 2 times 16 plus 4 divided by 2. This is going to give me the square root of 9 is equal to the square root of 2 times 16 is going to be 32 plus 4 is going to be 36 over 2. 3 is equal to 6 over 2, or 3 is equal to 3, and that solution works, and that is my correct solution. So it is x is equal to 16 in this case. Okay, for example C. First off, we have two possibilities. The one on the left is going to give me x is greater than or equal to 8. The one on the right is going to give me x is greater than or equal to 1/3, which means that x is greater than or equal to 8 is going to be my restriction. It covers all the possibilities. Second thing I'm going to do is, well, I could divide either the 2 by both sides or the 3 by both sides, but then I'm going to wind up with a fraction, and typically we don't like fractions because more often than not that's where mistakes happen. So I'm just going to start by squaring both sides. On the left-hand side, 2 squared is going to give me 4, and the radical squared is going to just give me the x minus 8, remembering to replace it with brackets. On the right-hand side, 3 squared is going to give me 9, and then bracket 3x minus 1. Then I'm going to multiply out both sides and say that I have 4x minus 32 is equal to 27x minus 9. I'm going to move my x's to the left and get negative 23x. And I'm going to move the 32 to the right and get positive 23, or x is equal to negative 1. And then as soon as I see this, I'm going to check here, and I can see right away that that is an extraneous root. It does not fit within the range of possible solutions. Okay, now this is going to be the first case that we've had where we're going to have this binomial on the outside, so binomial that's not in the radicals. We're still going to start it the exact same way. I have the possibility of x is greater than or equal to negative 5 over 2, or x is greater than or equal to 0. X is greater than or equal to 0 is going to be the one that I take. Now, the one side is already isolated, so I'm going to square both sides right away. The left-hand side is easy enough. It's just going to be 2x plus 5. On the right-hand side, I need to actually FOIL this out because it's going to be a binomial, or I can use my squaring binomials rule. I'm going to square the first term, so I'm going to square the 2 times root 2x and get 4 bracket 2x. The middle term is going to be the 2 root 2x multiplied by 1 and then double it because the middle terms are going to be 2 of the same. And I can say that this is going to be plus 4 root 2x. And the last one is going to be the last term squared, which is just going to give me plus 1. And I have 2x plus 5 is equal to 8x plus 4 root 2x plus 1. This is the first time that we've had it where we wind up with a radical still in there after we square both sides. So now I'm going to need to isolate that radical in order to solve it. So I'm going to move everything away from the radical. I'm going to subtract the 8x from both sides. I'm going to subtract the 1 from both sides is equal to 4 root 2x. Now at this point you can either choose to divide both sides by 4 and then square it, or you can leave this as a coefficient. Once again, I usually do just so that we don't wind up with mistakes when we're squaring it out. So I'm going to square out both sides, and I'm going to find that I have 36x squared minus 48x plus 16 is equal to 16 and 2x, or 36x squared minus 48x plus 16 is equal to 32x. 36x squared minus 80 plus 16 is equal to, 80x plus 16 is equal to 0. I can divide all this by 4, so I'm dealing with smaller numbers. 9x squared minus 20x plus 4 is equal to 0. And then I can factor this down into 9x minus 2 and x minus 2 are equal to 0. So I have two possibilities. Either x is equal to 2 over 9 or x is equal to 2. They both fit within my restriction up here, so now I need to check them both to verify and see if they actually work. So let's start by verifying the 2 over 9. And I'm going to say that if I have the square root of 2 times 2 over 9 plus 5 is equal to 2 times the square root of 2 times 2 over 9 plus 1, then that's going to give me the square root of 4 over 9 plus 5 is going to be the same as 45 over 9 is equal to 2 times the square root of 4 over 9 plus 1. On the left-hand side, I have the square root of 49 over 9. On the right-hand side, I'm going to have 2 times the square root of 4 over 9 is the same as square root of 4, which is 2, over the square root of 9, which is 3, plus 1. On the left-hand side, I have 7 over 3 is equal to 4 over 3, and I'm going to change the 1 to a 3 over 3. And I can find that 7 over 3 is equal to 7 over 3. And that solution definitely works. Oh, sorry. That solution definitely works. All right, now I'm going to check for 2. I'm just going to use the space over here to check for the 2. And I'm going to say that if I have the square root of 2 times 2 plus 5 is equal to 2 times the square root of 2 times 2 plus 1. The square root of 4 plus 5 is equal to 2 times the square root of 4 plus 1. The square root of 9 is equal to 2 times 2 plus 1. 3 is equal to 4 plus 1. 3 is not equal to 5. And here is my extraneous root.